Hi, and welcome to this tutorial on how to parallelize your Python code. The first step you want to do is create your environment. So I'm going to head off to Environments and call the navigator, click Create, select Python 3.7, and I'm going to call this tutorial. And I'm going to go ahead and click Select. You can be running this in PyCharm or any other IDE or any other code editor that you find suitable. But the essence of this part is to be able to create an environment to run your code. Now that I have the tutorial environment ready, I'm going to go ahead and install Jupyter Lab. So I'm going to go ahead and wait for that to finish. Sometimes the IDE acts a little bit funny and goes hiding, but we're going to wait for it. Now that Jupyter Lab is installed, I'm going to go ahead and click Launch. And there we have it. And I'm going to go ahead and create Python. And of course, go ahead and rename this. Okay, so the first step you want to do is pip install OpenCV Python. And this is just for the sake of this demonstration. You don't have to use this code, but just to see or just to benchmark how this method works on your computer. The next thing you want to do is pip install Ray. And Ray is the library we will use to parallelize the Python code. I won't go into the details of the architecture of how this library works. But if you guys want that, just please leave me a comment and I can go ahead and create another video. But I'll also leave resources for other videos where you can find other people who did a review for this library. Okay, now that this is finished installing, I will import the libraries that I'm gonna use for this demonstration. So that's CV2, NumPy, and I think NumPy comes with the Ray installation. So I'm going to go ahead and import that, and I'm going to define a simple function, and that simple function basically reads an image file. In our case here, it's image.jpg, and with a flag of 0, which means it imports it in white and black, an image of a Mercedes. Okay, so now that I'm gonna import now with this function here, the next thing I'm gonna do is the dot product of this image. And again, this is just an example to demonstrate how you can parallelize your code. So this can be any function that you have or any other two functions. So this function here imports, this function here gets the dot product. And to demonstrate the power of this, I will do 8 imports. So this can be 8 functions in your case. So I'm just going to change these to different names here just to demonstrate that it's a different function. Maybe I'm going to use one more just to demonstrate the power of the parallelism in this architecture. Yeah, I can go ahead and do this too. So again, I'm just repeating the dot product a couple of times. 6 here, 7. Yep. And maybe for fun, I will just merge all of them together. So let's say we're gonna call this merge array. I'm gonna rewrite all of them so I can just use the args to do that for me. Okay. And I got time. So I imported CV2 to read in the image. I used NumPy for the dot product, and I'm gonna use time to time how long it takes for this function to execute. So you do this by doing start equals start.time, and then the duration would be time minus start, and I'm going to print the duration. So basically, anything that goes between this box here is timed. Okay, and then now we're just gonna pass these functions here. So we will do, gonna give it a random name, and let's call dot image and import the image. So there we have everything there. Well, import one. So now dot image one calls it import one. Now I'm gonna repeat this for the other 8. Okay, so basically what I did is dot image one and imported the image and repeated the dot product for the image for different functions. And then I merged them together down here using this merge. I think I flipped this the other way. Yeah, time start. And basically the merge array takes the product of all of these and merges them together. Now I'm gonna go ahead and execute this by hitting Shift Enter. And it will print out how long. I realized that the dot remote here, so I removed that one. That was a typo. We will need that later, not now. So I'm gonna go ahead and skip till it's finished executing this code. And as we can see down here, it took 12 seconds to execute this. I'm just gonna copy this here for future reference. And now, how do we parallelize this code? So we can start from here. So if you have a function, or you have a set of functions that does some importing, so these are 8 different functions that import. These are 8 different functions that do the dot product, and then there's a third function that does the merging of these numpy arrays. Now, in a normal Python, it would first import this image to the dot product, save it in this variable, import the second image to the dot product and save it in this variable, and so on and so forth. And then finally, it would merge them all together here. Now, when you want to parallelize it, you want to execute each line or each function on a separate core to utilize all your cores. And that's where I did earlier, which is pip install array. Now I'm going to import it and I'm going to initialize it. So this is the first 2 additions you want to do to your code: import tray and ray.initialize. I'm going to hit enter. It actually starts this dashboard right here. It doesn't work on Windows 10 as of March 2021. So here we see the cores. So you can see it was a bit busy for a second since it was initializing. And on my computer, I have 12 cores. So on your computer, you'll probably either have more or less. It's not the same. So this is going to depend on your cores. And basically, the more cores, the faster your code will be, since it can parallelize more. Just a bunch of information here. And now, if you want to parallelize this code, all you have to do is call the decorator by using @ray.remote, and then you just paste that on top of each function that you have. So we'll go ahead and paste them on all the functions. So now that I have pasted them on top of all the functions, the next thing you want to do is basically dot remote into the function and pass this as the variable and another dot remote in here. So I'm going to repeat the same for all the functions. So what I did is dot remote, and I did the dot remote down here. And then one extra line is ray.get results. And I'm gonna click execute by Shift Enter. And there we go, 3.7 seconds. I mean, that is amazing. That's mind-blowing. I mean, you went from 12.4 seconds to 3.7 seconds by simply importing Ray, initializing it, adding the decorator on top of your function, and then adding dot remote on the functions call down here, and then finally adding an extra line. It's truly incredible. Now I can keep on re-executing this. So let's see what's it, 3.2 seconds. So because it's already initialized. And here you'd see your cores, which ones that were busy executing it. It will definitely be 8 cores because I have 8 functions. But if you were to increase it, then you would have more. Okay, that was it. Please let me know if you have any questions. Please don't forget to click the like and subscribe button if you enjoyed this video and would like more updates when it comes to parallelized coding in Python. Thanks.